Today's topic is dielectric strength. Before going into the topic, the very purpose of education is concentration, said by Swami Vivekananda. That means whatever work you carry out, you should concentrate and do it. So once again I repeat, the very purpose of education is concentration, by Swami Vivekananda. Okay. Now coming back to dielectric strength. When the external electric field applied to a dielectric is very large, it tears the atoms apart so that the bound charges become free charges. Then the dielectric starts to conduct electricity. This is called dielectric breakdown. That means you have two plates and you are giving a potential. Assume air is there. If you keep on increasing the potential, at one point the air will start conducting. That is, basically any dielectric is bounded with the parent structure. So nucleus, first orbit, second orbit, third. So all the electrons will be bound to the parent atom. But because of the very high electric field, what will happen is these electrons will come out of the parent atom and becomes free charges. So once you have free charges, it will start conducting electricity. That means even it is a dielectric or an insulator, so the insulator also will conduct electricity. Okay. So the statement can be made this way also. The maximum electric field that dielectric can withstand before it breakdowns is called dielectric strength. That means you assume two plates, the distance between the plates is 1 meter. Assume air is filled between these two plates, and between the two plates you are giving a voltage of 3 into 10 power 6 volts. That is 3000 kilovolts. So what will happen is you have air between these two plates. If the value goes slightly increasing, that is slightly above 3000 kilovolts, the air will start, the dielectric breakdowns and the air will start conducting. That means even though air is an insulator, it will start conducting. Suppose you are filling this area, this portion with mica, and the distance between the two plates is 1 meter. Now you are giving a voltage of 100 into 10 power 6, that is 100,000 volts, kilovolts, 100,000 kilovolts if you are giving, that is 100 into 10 power 6 volts if you give, even the mica will start conducting. Slightly above this value, the mica will start conducting. That means all these insulators will start conducting once you cross this dielectric strength. So mica, it is dielectric strength is 100 into 10 power 6, Teflon 60 into 10 power 6, paper 16 into 10 power 6 volts per meter, air 3 into 10 power 6 volts per meter, Pyrex glass is 14 into 10 power 6 volts per meter. So this kind of when air starts conducting, you can see spark. Okay, the spark means it is the energy is converted into light as well as heat, that you can see. If you see there's on and off of switches like grinder, mixie, or washing machine. So when you switch on and switch off, when the switch is closed at the time of closing or at the time of opening, what happens is you can see a spark. If it is fully closed, no spark is there, or fully open, no spark is there. But at the time of closing or opening, the distance between the two plates is very small. Therefore, you will be seeing the spark. Okay. So the idea is even the insulators will start conducting once when the voltage applied to the dielectric exceeds the dielectric strength, that is 100 into 10 power 6 volts per meter is the dielectric strength for mica, and for air it is 3 into 10 power 6 volts per meter. So that's what I did. You take two plates, separate the distance between the plates as 1 meter, and if you give 3000 kilovolt, taking air as the dielectric, and any slight above this value, slightly if you increase, then this air will start conducting. So the conclusion is even the insulators will start conducting once it crosses the dielectric strength. Hope you have understood the idea behind dielectric strength, and even the insulators will start conducting. Thank you for your attention. Nandri.